Okay, question 18 is a find the inflection point question, except that the question they'll be giving you requires you to be very strong in algebra to be able to not make any mistakes and proceed up to the second derivative and set it equal to 0, right? And solve for x. Right? So step 1 is to actually find what this expression is. Step 2 is to set that equal to 0 and solve for x. And getting here to here requires you to be strong in algebra. I also put quadratic formula because when you get here, you will need quadratic formula to finish the question off and to get one of the multiple choice answers. It's also fairly obvious that you do need the quadratic formula because when you look at the multiple choice in this question, there's a lot of root answers, things that look like this, and that means it's not factorable, and you do need to use quadratic formula to get these irrational roots. Okay, so let's proceed to the solution. Okay, point of inflection occurs when the second derivative is equal to 0. Okay, so we need to find the value of x which satisfies this condition. So the first step is to find the second derivative. First derivative first. So 2 over 3 minus 1. Chain by the derivative of what's inside, so it's 2x minus 3. Okay, so that's 2 over 3, 2x minus 3, all over x squared minus 3x to the power of 1 over 3. Okay, that's negative 1 over 3, but so that's the same thing as over 1 over 3, right? Okay, so we got to do it one more time. We can leave the constants out. This time our quotient rule. Okay. So I'm differentiating the bottom part, starting from right there. And chain it by the derivative inside again. You get 2x minus 3 all over the square of the bottom part. Oops, I forgot the 1 over 3 there. Okay, so the best thing for you to do here is to factor out this here with the lower power, which is negative 2 over 3, as well as 1 over 3. That gives us 6 x squared minus 3x. This becomes this 1/3 becomes power of 1 minus 2x minus 3 squared all over that. Now, both this, because of the negative exponent, can come under, and 1 over 3 can be just multiplication of 3 at the bottom. So the 1 over 3, I'm going to pull it out as 2 over 9. And the denominator becomes x squared minus 3x to the power of 4 over 3. In the numerator, we get 6x squared, 18x. Subtract by 4x squared minus 12x plus 9. Okay, so we just have to collect the like terms. 6 minus 4, that gives you 2x squared, minus 18 plus 12, that gives you minus 6x minus 9. Okay, so where does this equal to 0? The only thing that matters is this guy at the top. Okay, so you can either try to factor or use a quadratic formula or complete the square. Now, looking at the multiple choice, I know it's not factorable. So I'm going to jump straight into the quadratic formula. Let me just state the quadratic formula right here, just in case you guys don't remember. Okay. So minus b plus minus b squared minus 4ac all over 2a. So that gives you 6 plus minus 36 minus 4a minus 9 all over 2 times 2, 4. So look, there's 36 here, but also 4 times 9 is 36 also. So I can factor that out. And I get 1 plus 2. That's 6 plus minus 6 root 3 all over 4. Divide top and bottom by 2. So if you factor 3 from the top and 2 from the bottom, we're left with this. So it has an inflection point right there. Okay, everything else, it looks similar, but it's neither one of the choices. There's two choices here, one plus and one minus. There's a plus, but everything else is actually different.